Hello, in this video we're going to use the R programming language to build a neural network model, and we're going to use the same data set that we've used throughout the quarter. We're going to use the home equity line of credit data set. So let's start off with, we're going to need to download the neural network package that we're going to be using. So to do this, as we've done earlier in the quarter, we have to come up here to packages. So we are in the, well heck, let's start R from scratch. Just let's mix it up a little bit. So let's open up R, and this is what it looks like when you open it up. Now you're going to come over here to packages, and you're going to click on that, and we're going to set our crayon mirror, and that's where all of the R packages are that we can download. And they ask you to choose one that is close to you. So this is the one I'm going to choose, the one near Cleveland, Ohio. And now we're going to go to the packages, and I'm going to install, and we'll wait for it to come up. And the one we're going to want to use is NNet, neural net. And so we come down here, and it should be up here shortly. Here it is. Click on this guy and hit OK. So it's going to install. Now again, this is not a programming class. But it's nice to know what the people who build predictive models, it's nice to understand the tools that they are using. So we're just gonna, this is just a demonstration, and to get people who are managing teams of analysts or work alongside of them, this gives you an idea of what they're doing. So okay, let's open up this file. Now what we're going to do here is we're going to do the same thing that we did before. We're going to build a decision tree using RPart, which stands for recursive partition, and we're also going to build a neural network. So let's start off by doing what we did before, and we're going to just read in the first couple of variables here, or we're going to read in the data set like we did before, and then we're also going to print out using the head command the first 6 records. Now there's going to be a slight difference here. The difference is that with the neural network package that R has, the neural network, everything has to be normalized. So let me explain what that is in just a moment. But first I want to just summarize the data. We've already printed off the first 6 records, but let's summarize it now too. And when I do summary of our data set, you can see that, for example, my imputed loan value, the lowest or the smallest value is $1,100, and the largest one is $8,990. The mortgage due, the smallest one is 0, the highest one is $399,000. So you're getting a feel for the highs and the lows and the means and the medians of all these guys. Okay, now the neural network package in R needs to have the data to be normalized, and that means we're going to put it on a range of 0 to 1. So if the value of the loan is $1,100, we're going to substitute in a 0. And if it's $8,900, the biggest one, it's going to be a 1. And it's just going to be anywhere along these lines. So how you do that is I'm going to take my imputed loan, and I'm going to subtract $1,100 from it, and I'm going to divide by the maximum value minus the minimum. Now, some of these other guys I don't have to subtract out the minimum value because there's zeros, so we don't even need to do that. So anyways, when I run this code, what will happen is all of my variables, when I run this, now if I summarize the data, you're going to see that the lowest value is now 0 for every one of these, and the highest one is going to be 1. So now everybody is now standardized, or excuse me, normalized. And in fact, if I do print, I just print the first 6 records, you're going to see everybody's got a value between 0 and 1. Okay, so now let's just go and do what we did before. Do a little housekeeping here. Now let's build a decision tree. Now the decision tree is not going to be affected at all by the fact that these records are normalized. The decision tree is just going to split them at different values, but the tree is going to look essentially the same. So let's take a look and just run that guy. And you can see now the decision tree, because everybody is normalized, he splits on the same values, but now they're just normalized values. But now we're going to build ourselves a neural network. Now what's the command for that? Well, it's just going to be neural net, and we're going to run this guy just like we did before. And then over here at the very last command, we have to say how many nodes are in our hidden layer. And I just threw 10 in there. It could be anything. So let's do that real quick. So there, our neural network has been trained. Okay, now let's score some new data. Now in this case, as before, we're just going to take our training data set and copy it into a new data set that we're calling test. We're going to pretend this is new data. It's not really. But we're going to score the data for the decision tree. And now we're also going to score it for the neural network. There we go. And the next thing we're going to do is we're going to do a ROC curve for the decision tree and the neural network. And let's plot these guys. And this is the black and white version right here. Oops. This is the black and white version. The first one is the black and white. And voila. And here's our decision tree again. And this is our neural network, much more accurate here. Now, I don't know if we can believe this to be truly that much better, because we are testing on training data sets, and machine learning algorithms are notorious for overfitting. So when you're dealing with a neural network or a support vector machine or even a random forest, it's probably a good idea to have a holdout sample, but we're not doing that for this exercise. I'm just trying to show you how a neural network is trained in R. Now the next thing we're going to do is let's build ourselves a ROC curve, and this time we're going to do it in color. Look at that. That's a good looking ROC curve if you ask me. Look at that thing. Okay, so finally let's look at the area under the ROC curve. And the decision tree has 84% of the areas under the ROC curve. And let's take a look at our friend the neural network. And this guy is 92%, 93% there. So, okay, so this is how you generate a neural network using the R programming language.